Hello everyone, let's continue our course. In this section, we will discuss the procedures after UE power on. First, after UE power on, actually UE will perform the PRMN selection procedures. Look at these pictures. When UE is powered on or recovers from lack of coverage, then UE will attempt to select the last registered PRMN. This means if this UE is not the new mobile phone, UE will try to select the last registered PRMN where UE stays. Actually, UE already restored the information about the last PRMN. And this time, when UE come back, recovered from the lack of the coverage, we will try to select this PRMN again, if it's any possible. But if this is a new mobile phone, UE doesn't restore any information about the network. UE will scan all the frequencies which supported by the UE until UE find out a network and try to stay in that network. Okay. When UE attempts select the last registered PRMN or scan all the frequencies of the network, UE first will perform a cell selection procedures. Actually, before the cell selections, we also have the cell search procedures and the MIP and the SIP reception procedures. First, the higher layer of the UE send a request to the physical layer of the UE. All of this message actually is the interlayer message within the UE. Here, this circles means invisible message, which means the signaling we cannot trace from the network side. And the partial visibles, which means this message we can only trace at the layer 2 of the UE. And the visible here means the signaling we can trace at the layer 3. Here, the cell search procedures is performed by the physical layer of the UE. Actually, it's based on the request of the higher layer. Higher layer asks the lower layer to search the cell to find out a network. Then UE perform the cell search procedures. After that, if UE find out any network, UE will read the MIP message and the SIM message from that network where UE just found. And based on the MIP message and the SIM message, UE will select a cell based on the criterion from the MIP and the SIM message. After the cell selections, UE will perform the cell PRMN selections response. And if the PRMN selection succeed, then UE will stay in that cell, compound the cell, and waiting for the paging message, or if users initially set up the services. After that, UE will perform the random access procedures, connect with the network. After that, UE will start the services. Okay, this is the general procedures for the PRMN selections. If the registered on the selected PRMN successful, then this procedure is finished. If no, the UE will search for another PRMN according to the information in the USIM card and go back, perform the cell selection procedures again until find out a PRMN network. For the cell search procedures, actually is the start point for the PRMN selections. In cell search procedures, we have almost this 4 steps. The first step of the cell search is the PSS decoding. The second step is SS decoding. The third step is the reference signal measurement. And the fourth step is the broadcasting channels decodings. Now let's discuss the details for this 4th step. The PSS decoding here means UE will read the primary synchronization signals and perform the slot synchronizations. Here, slot synchronization, which means UE want to find out the start point of one slot, find out at which moment is the start point of one slot. By the way, in LT system, one frame equals 20 milliseconds. One slot equals 0.5 millisecond. In one frame, we have 20 slots. If UE know the start point of one slot, that means UE will also know all the start point of the slot, all the slot start point. Okay, after UE find out the start point of one slot, which means UE finish the slot synchronization, and then UE will perform the frame synchronization. Here, frame synchronization, which means UE will find out which moment is the start point of one frame, which means which slot is the slot 0, the first slot of one frame. After UE finish the slot synchronizations and the frame synchronizations, UE will obtain the physical cell ID. We call it PCI. After UE get the PCI of the current cell, UE will use the PCI to decode the reference signal and the broadcasting signals. So the third step, UE will read the reference signal of the cell. If UE read the reference signals, UE will measure the signal qualities of that cell and the signal strength of that cell. Here, RSRP here means reference signal received power. RSRQ here means reference signal received qualities. RSRP indicate the signal strength, like the RX level in GSM. RSRQ indicate the signal qualities, like the ECNO in WCDMA. One indicate the signal strength. Another here indicate the signal qualities. RSRP and RSRQ is measured by the UE based on the reference signal received from that cell. After UE measure the signal qualities and the signal strength, then UE will continue to receive the broadcasting message from that cell. The MIB and the SIB is the broadcasting message sent by the broadcasting channels. MIB here means master information block, and the SIB here means system information block. After UE get the PCI, PCI here is just like a key. UE use this key to open the broadcasting channels. If UE decode the broadcasting channels, UE can read the MIB message and the SIB message. We have many important messages carried by the MIB and the SIB. This is examples for the MIB message and the SIB message. For the optimization engineer, we will configure a lot of parameters on the network side, especially on the eNodeB side. For example, the cell ID, the frequency of the cell, the tracking area code, and also the PLMN ID. All of this information we configured on the eNodeB. But those information is very important for the UE. UE must use this information to connect with the network. This information is important for the UE. But how UE know this information if we configure this information on the network side? Okay, so this is the usage for the system information broadcasting. The broadcasting message carry those information from the eNodeB to the UE. eNodeB actually every time they broadcast those message to the users. This is the broadcasting message. We have two types of broadcasting message. One is master information block. Another is the system information block. This is the content of the master information block. We call it MIB for short. Look at these squares. This squares shows the content of the MIB message. In the MIB message, there is one information. It's very important for the UE. Here, downlink bandwidth. This is the downlink bandwidth, indicate the bandwidth of the downlink. In LT systems, LT support 6 different bandwidths from 1.4 MHz to the maximum 20 MHz. Here, N100. N100 means 100 RB, 100 resource block. which means the bandwidth is 20 megahertz. Besides the downlink bandwidth, MIP message also tells this information to the UE, system frame number. We know that we have many frames. One frame equals 20 milliseconds. And for each frame, we have a number. Just like for each day, we have 24 hours. For each hour, we also have a number. For example, 8 o'clock, 9 o'clock, 10 o'clock. For each hour, we have a number. For each frame here, frame is used for the synchronizations, just like the clock, just like the hours and the minute. And also for the frame, we also have a number. So this number we call system frame number, SFN. MIP message tells this information to the UE. And for the SIP1, this is the content of the SIP1. As we can see, many other important information is carried by the SIP1. Here, look at here, the MCC and MNC. MCC here means mobile country code, and MNC here means mobile network code. MCC and MNC actually is the content of the PRMN. PRMN, we know that means Public LAN Mobile Network. PRMN is used for the identification of the operators. We use PRMN identify an operator uniquely all over the world. And so MCC and MNC, actually they are the part of the PRMN. One PRMN equals MCC plus MNC. Here MCC equals 460. Mobile country code use this 3-digit indicate a country all over the world. 460, this code is for China. And the mobile network code, MNC, use 2 numbers indicate an operator within this country. In this example, it's 01, which means China Mobile. 46001. Use this 5-digit, 5 number, we can identify an operator uniquely all over the world. And for the SIP1, we also have some other information like the tracking area code and the cell ID. And also here, for these parameters, Q, RX, level min. This is parameters for the cell selection. So for the SIP1, a lot of important information is carried, like the PRMN ID, the tag, tracking area code, the cell ID, and the parameters for the cell selections. For the SIP2 and the SIP3, look at these examples. SIP2 carry the physical channel config information, and the SIP3 carry the cell reselection parameters. The other SIPs, except SIP1 and the SIP2, actually is listed in these circles. The other SIPs, for example, the SIP4, SIP5, SIP6, SIP7, the other SIPs, some of them is unnecessary. Sometimes we cannot trace those SIPs from our UU interface. These is examples for those SIPs. Okay. Different SIPs like MIP, SIP1, SIP2, SIP3, different SIPs, they carry different information. For the SIP1 and the SIP2, these 2 SIPs is very important for the UE. This is the necessary SIPs. The other SIPs is unnecessary. They carry some unnecessary information for the UE. This is the information carried by different SIPs. You can see the SIP1, SIP2, and also the other SIPs. Here, I need to mention the ETWS here. The ETWS here means earthquake, tsunami, warning system. It's kind of a services, provide the warnings for all the mobile phones stay in these cells. And the MBMS here means multimedia broadcasting multicast services. For example, mobile TV is one of the MBMS services. SIP 11, SIP 12, and the SIP 13, they are used in some special case. Normally, in our live network, we don't have those SIPs. SIP 1 and the SIP 2 is very common and very important. They are the necessary SIPs. Thanks for watching.